1. The inventory was lab 1A instead of me coming back and renumber all the labs. So this is according to industry standard. So basically this is a circuit, and the circuit runs from bottom to top. This is after the service unit, but we're going to do one more thing that I just noticed that's not on it. So we have a service unit. The service unit's got a disconnect on it. It's not the disconnect, but it's got an off-on, I guess you should say, switch. Then it's got a manifold. Well, all that is prior to this. So this is basically where you enter for your circuit. Everybody okay? Yes or no? So we'll come down from the T at the top. We'll drop down and come into the inlet on our service unit. Then we'll take the outlet of our service unit, which is a 1/4 inch hose, and then we'll run it into the manifold. And you see what the manifold does is it's got check valves in it. As soon as I get to my camera. Switch over to the other camera. Oh, this will be good. Oops. So this is the manifold. And actually, if you looked at the, well, they don't show it, but it's got a check valve in each one of them. So, but it's a pressure activated. So it's like, if you don't put a hose in there, then it automatically seals itself. And these are quick disconnects. You know how they work? Everybody okay? So what you do is, when they get pressure on them, they're going to pop out and seal. And then what you have to do to get the hose out is you just have to push them down. Oops. And then pull the hose out. Everybody okay? This is the 1/4 inch. So feeding from our service unit will come in here, and then we can take 1/8 of a valve, and that's all we're going to do, guys. Because what I want you to do is I want you to do it the way we would have an industry. So if you ever go to your circuit breaker and you look at circuit breaker, how many wires come into a circuit breaker in a panel box? 1. Well, how many outlets do you have on that thing? You got a bunch, right? Well, all the jumping is done out the side there. Okay. So basically, the manifold, all we're going to do is all we're going to do is convert a 1/4 inch over to an 1/8 inch. That's all we're going to do. And then what's not on the list is we're going to run it through one of these. And I think it says on the lab, it says include an e-stop. I think it says hopefully it says that. Did it say that, guys? Let's see. Yeah, e-stop valve between the manifold and 1D1, which is this guy right here. So this is an e-stop, and it's a true e-stop. Let's see, right there. So to be an e-stop, first of all, it's got to have a mushroom button on it, and it's detent, and it's a latching button. So that means when you press it, what does it do? It locks down. And a true e-stop button, you can't pull it back out. What do you have to do? You have to turn it and pop it up. So what you're going to do is from your manifold, you're going to run it into this. And then the output of this is going to be right here. So the output of your e-stop is going to be coming into your first, what's that? What's that valve right there? We've only got one valve. That valve right there. Three, two-way. Start off with the number of ports, followed by the position, by the term way. So it's a 3 two-way valve, manually operated spring turn. So this is going to be when you push that valve. It's got the push button. Okay? Make sense? And then we'll take the output of that and run it up to a single action cylinder. Everybody knows a single action cylinder. So that's a single action cylinder with a magnetic piston on it. We'll figure out how to use that later on. That's the first lap. So notice how it's numbered. So the actuator is called 1A. If you got individual circuits, then it'd be 1A, 2A, 3A, right? So the actuators are labeled A. Then your valves are labeled 1. You start on the left-hand side. So let me bring up, and while we're going to do it, here everything's labeled for you, but eventually you're going to have to start doing what? Label it. Yeah, I'll give you the diagram and you'll have to label it. And then eventually you'll have to come up with your own circuit. Of course, when you do that, you'll have to label it also. So this is the Amatro line, and this is, well, let's choose the module. And then we'll look at the pneumatic diagram. So this is the pneumatic diagram. By the way, 1B1, 1B2, these are position sensors, which we do have them up there. So 1B1, 1B2, so those are sensors, right? They sense the see if it's fully extended or not. But what we do is we come up, so this is where we're starting at. Then the first valve you see on the left is going to be called 1B1, right? You understand? And then you come up here, this would be what? 1, which means it belongs to circuit 1, right? It's a valve, and it's the second valve. Y'all see that? And this right here would be what? I'm sorry. This right here would be 1B3. So we number them from left to right, from bottom to top. And then this would be 1A. So 1A stands for what? Actuator. V is for valve. B is for sensors. And this is in M. M is for solenoid. So these would be solenoid action. This would be double solenoid actuated with mechanical override. Manual override. And this is a service unit. And this would be the e-stop button right here, which is what we got with it. That makes sense? Yes or no? Okay? Okay, so where our diagram starts at is after the e-stop. So that's where it shows the power unit. That's going to be after the e-stop. And then then this is what you would run into. So we have these things right here. Instead of just running everything back to the manifold, so we'll have one tube literally going into the manifold for all our circuits. This right here is obviously this is what we call a T. You see how that works? So this is what we would run our tubings in. We'll tap off. We could have as many T's as we want to. Does that make sense? Yes or no? So I think if we look at the second circuit, I'll go ahead and bring it up to, because some of y'all get to hear. No, we don't use a T here too. So what's these symbols right here? So this is a 5-2-way valve with a detent on it. So this is the valve that's got the selector to it. You know what I'm talking about? Yes or no? So when you put it in one position, it stays over there. And we go get the valve and show it to you.
They advertise in their business. And, that's what I found out there. Even the,
I'm just killing.
PDF.
No. What do you, no. Anytime you see 2 squares, you got 2 positions. When you see 3 squares, you got 3 positions. So that's all we're going to have. We're going to have 2 position valves and we're going to have 3 position valves. Right now we're dealing with 2 position valves. Then we count the number of ports. How many ports does this guy have? 3 on the bottom, 2 on the top. It's a 5-port valve. Right? Everybody okay? Got 2 exhausts.
So we got position, we got port, and
Ways.
ways.
No, ways or ports. Ways and ports are the same thing. We just don't say 5 port, 2 position. We say 5 2-way valve. So the ways are the number of ports. But that's the industry standard on specifying the valve. You start off with the number of ports, then you say the number of positions, and then you say way. Now, why do they do it that way? I don't care. That's the industry standard. Okay.
Then I see the arrow that seems to be the same as the little T's, the little ports.
Oh, okay.
The arrow's right there. I mean, how we make that? What do we say for those arrows that I'm looking at?
These arrows?
The black arrows.
The black arrows are the directions. That's why they call them ways. So it has 5 ways or 5 ports that we can route the air through. So in this position right now, power, here comes the fluid power. Okay, I'm sitting right there. So 1, notice how the valve is numbered. So number 1 is always the pressure port. Your odd numbers are your pressure ports. Your even numbers are your working ports. Okay, so 1, 3, and 5, these are your pressure ports. In 3, you only got 1 pressure port, so 3 and 5 got to be what? Exhaust, right? And then we say your even numbers are your working ports. These are the guys that are controlling your actuator. So I can't draw on this, but I'll trace it. So here comes the power. Here comes the fluid power. Comes up here, hits on 1. Which way is it going, Franklin? It's following that arrow. It's going to go up this direction. It's going to come out of port 2. It's going to come over there and call that cylinder, do what? Extinguish. 2 and 4 are working ports. Now notice it comes up 1, then it goes to the right, then it comes straight down, then it goes up. Y'all see how the numbering goes? So it comes up 1, and then it goes towards the right. Then it comes straight down. 1, 2, 3, 4, 5. So it's making, see the X is making, yes or no?
I'm kind of following you now. So it went up to that side and it came straight down to that 3.
No, it's not coming down to 3. It's coming up here. It's not coming down to 3. 3 is blocked off.
Okay, 3.
I'm just telling you how it's numbered. So this is the way we number the valve. 1 is the pressure port. And then when you come up to 1, which way do you go numbering? You go to the right. 2. Then you come straight down. That's 3. Then you go over 4 and then down to 5. And so if it's a 4-port, you go 1, 2, 3, 4. Right? You understand? So what's this guy going to do? Well, it's going to do nothing because it's sitting over here to this. There's no pressure. You got 0 pressure on that side. You got 0 pressure on that side. Now what do you got a picture in your head? You got a picture when I come over here and do this, that valve shifts over. So what's that going to do? Well, that's going to take this, and it's going to be coming out. Now it's going to be connected to what? Huh? Over here? No, 4 is not. It's still 2. It's just misnamed. But this is 4 right here. It's going to take over, and 2 is going to shift over here. Right? You understand? Now 2 is going to be what? Ported to what? 3. So what's that? Ported to 3. So that's exhausted. We got a spring pushing on this side. We got this one going to 0 pressure. So what's the valve going to do? It's going to retract. Now, this guy is going to be lined up with 1. So one's going to come up here now and go up through here, and it's going to go up, hit the motor's going to spin. But what you got to do, and the hardest thing for people to do, is visualizing that valve doing what? Sliding. And they got the numbers on the wrong. This 4 should be on the other side. This is not port 4. This is port 4 right there. So 1, 2, 3, 4, 5. This is not port 5 right there. This is port 5 right here. So the numbers are misleading on this diagram. We don't have any numbers on the left block because it's not in play, right? You understand? Yes or no? Yeah, so that looks, I can see where that might get got y'all's problems, guys. And this is done by an application called Viso. And I don't know, I don't like the way it does. So that is not 4. This is 4. Y'all understand that? And this is 5. So right now, the way it's drawn, they shifted their numbers, I guess, because they couldn't get a 5 down here. And it looks like it's on the left-hand side. But all your numbers are in the normal position. Huh? Well, the problem is the symbol's so small, they couldn't put the 5. They could have put the 4 right there, but they didn't. They put the 4. Yeah, but we know, y'all know now, right? So what you're doing when you're looking at the numbers, you're looking at what we call the initial position of the start. And now what's going to happen? So I don't know which position is the normal position. I guess this is the position over here because that's the DC. But if you turn it on and your motor starts running, it just means that this guy right here is not in the initial position, right? Are you okay? Any questions? Yeah, so I'm sorry about that. Are you okay? So what are we going to use here? We're going to use this T, right? One of these T's. So this is the symbol for a T. They don't draw the T. They just come in. It comes in as a T. You don't see why it's called a T, right? So this is where you're going to put one of these guys. And then one of them's going to go up to your, what is this? No, there's no check valve in there. The only check valve is in that manifold. So that way you can put pipes up. All we're going to use that manifold for is to reduce it from a 1/4 inch down to a minute. So we'll only have one pipe going, and all your piping is going to be done out. And that's the way it will be. So if you ever came over to your compressor, you'd see one pipe coming. So all your piping and all your splitting is done out in, it's like your house, right? You go and look, open up, you pull that panel off and look at the breaker, you're going to see one wire going there, but you might have 8 plugs and 2 lights up to that. So all your jumping is done where? Out inside your house. That makes sense? So no, these are not quick disconnects. These are quick disconnects. There is no check valve in here. So what happens if you don't seat that thing in there good and you throw pressure on it, what's going to happen? Pipe's going to pop out. And what's it going to do when it pops out? Right. Everybody plays around with a hose. In fact, you used to buy the thing you put on the end of the hose and make it snake all around. They probably made those things illegal. Everybody got some. They do. So this is 3 labs, and this is probably all. Probably y'all not going to get here, but see how this guy's going to work. So we start off. So this is a what? Five, 2. We don't, but we don't say that. We say 5 two-way valve. We don't say position. We say 5 two-way valve. That's the way. And if you look at the data sheets that's the way they're labeled. Guys, I know it's backwards. I know it's a 5-way 2-position valve, but just over time, that's the short thing, that's the way it is. So this would be a 5-2-way valve, pilot actuated. But what we're going to do with this valve is 1V2 is we're going to use air to shift that valve. So we'll run a line out of this valve. So this valve is going to determine the direction of this valve. So it means right now this valve is going to be in the right, it's going to be in the position drawn. And which valve is this? It's a detent. So this is the detent valve right here, right? You understand that? Yes or no? So once I flip this switch, it's going to take air out, going to push it here. Now the air is going to push this over to the right. And notice these numbers are wrong again. This is 4 and this is 5, right? Understand? It's going to cause it to shift over. So right now in this position right here, air will come up through here, go in 1, go out 2. 2 is going to retract the actuator or pull it. Nancy liked to use the term pull and push. And then when I come over here and take this selector switch and select it, it's going to push the valve over. Now, this is going to go up 2, right? You understand? What's that going to cause to happen? Push it over, right? Now, this pressure is going to come up and it's going to go route it out to here. And this is going to be 4. 4 is going to come up. It's going to do what? Push it out. On this side, what are we going to do with the air? Well, it's going to come over here. It's going to go out 4. It's going to come out. It's going to exhaust. And so that's going to allow this to extend.
You really got to visualize that while you're moving, because if it's lost, you got to see it.
You got to see it. You got to see that in your head, and you can understand they can't animate it. And that's the biggest problem we have with this is people doing what? Visualizing that valve, that spool in there shifting. If we looked at the prints on the Amatro line, you see it's the same way. So this is the first 3 labs. Y'all got any questions on this? Huh? So we'll work on lab. I'm giving out lab 1, and the other labs are going to